So let me ask you guys, the prefix bi means what? Two, like a bicycle, right? Has two wheels. So we're going to be multiplying binomials. That means two monomials, right? It means a polynomial with two terms. We're going to be multiplying a binomial times a binomial. Start with something simple, and then as the week progresses, we'll do so this will be a 2 by 2. Maybe tomorrow we'll do a 2 by 3. And then Wednesday we'll do a 3 by 3. Maybe we'll do a review on Thursday. Somebody in the last class had brought that up about reviewing maybe before a quiz. I doubt anybody would be opposed to that, right? Is anybody opposed to That's funny. Okay. So what I want to show you first is why this method works. And in order to do that, we're going to use some numbers, right? Because with variables, you can't do this. But let's just talk about, for example, if we had 2 plus 3 in parentheses times 4 plus 5. With numbers, you can combine what's in the parentheses. In fact, with PEMDAS, you do what's in parentheses first. So 2 plus 3 is 5. Over here, you would have 4 plus 5, which is 9. 9 times 5 is 45. Now, the method we're about to do is you're going to take the first number in the parentheses 2 and multiply it by each number in the second. So I'm going to do 2 times 4 plus 2 times 5. And then after you multiply the first number by the binomial, then you take the second number and distribute 3 times 4 and then 3 times 5 down here. So it's just like multiplying a monomial by a polynomial, except you have two terms now to deal with. So we're just doing it twice. If I simplify this, I have 2 times 4, which is 8, 2 times 5, which is 10, 3 times 4, which is 12, 3 times 5, which is 15. And if I add them all up, 8 plus 10 is 18, plus 12 is 30, plus 15 is 45. You'll notice that you get the same answer. The second one requires a lot more work, but the reason why I did that was to show you that when you multiply a binomial out this way, it's equivalent to doing it this way. And because if we have variables over here like 2 plus x, or let's say x squared plus 3x, you can't add them, right? You have to do it this way. And we will be dealing with binomials, so we'll have to do it this way. But again, we do it this way just to show that it works, that they do equal each other out. There is another way called foiling. It's actually basically the same way, but the order is different. You would do 2 times 4, which is your first. That's what the F in foil means. 2 times 5, which is outer, which is the O in foil. 3 times 4, which is your inner, the I in foil, and then 3 times 5. But notice it's the same thing, just in a different order. All right, so let's actually do an example with variables. So we have 4x squared minus 2x times 2x to the fourth minus 7x to the fifth. So the first step that you're going to do is distribute each monomial. So what that means is you're going to take the first monomial, multiply it by each term in the second. Then you're going to take the second monomial and multiply it by each term in the second polynomial. So here's what this looks like. If I take 4x squared and multiply by the first term in the second polynomial, I'll get 4x squared times 2x to the fourth. Then when I distribute it again, so what's the sign in front of 4x squared? It's not there, but it's plus, right? So you put a plus 4x squared there. Then what's the sign in front of 7x to the fifth? Minus. So you cannot forget to put that sign there. If it's a plus, you put a plus. If it's a minus there, you put a minus there. Okay, and of course the sign here is plus, so we have plus there. So that's the first monomial distributing to both. Question, yes?
Why do you distribute the negative 2x to the negative 7?
We are. Okay. It's right below here, right here. So after you distribute the 4x squared, then distribute the negative 2x, there's a minus in front of there, times the 2x to the fourth, so that's this, and then take the minus 2x and distribute it to the minus 7x to the fifth. So that looks like this. You're going to have a double negative. So if you think about it, if you're multiplying a binomial times a binomial, once you multiply and distribute, you should have 4 terms, or 4 different multiplication problems. Your next step is to multiply those monomials together. So again, you should actually have 4 different multiplication problems. 4x squared times 2x to the fourth is, 4 times 2 is 8. X squared times x to the fourth equals what? Somebody? No, x squared times x to the fourth. Yes, you will add the exponents. So it'll be 8x to the sixth when I multiply the first 2 terms. Second 2, 4x squared times negative 7x to the fifth equals negative 28x to the seventh. Yes, that is correct. So it's a positive times a negative, which is a negative. 4 times 7 is 28. X squared times x to the fifth. Add the exponents to get 7. Next, negative 2x times 2x to the fourth. Notice I put in the missing 1 there for the exponent. So negative 2 times 2 is 4. X to the first times x to the fourth equals x to the fifth. So it should be negative 4x to the fifth for the third. And finally, negative 2x to the first times negative 7x to the fifth. Negative times a negative is positive 14x to the sixth. And we are not done yet. That's just step 2. Step 1, distribute. Step 2, multiply. Step 3, order in descending powers. So that means the highest power first, followed by the next smallest, followed by the next smallest. So we put the x to the seventh term first, followed by these 2 x to the sixth terms, and then lastly the negative 4x to the fifth. Step 4, I'm sorry. Step 4 is to combine the like monomials. So notice these 2 in the middle both have a term of x to the sixth, so we need to add the coefficients, and we will get 22x to the sixth. 8 plus 14 is 22. So now we just have 3 terms. Step 5, simplify, right? So if there's any, say we have exponent of 1, we can just remove the exponent. If there's a coefficient of 1, we can remove it. Anything times 0 is 0. All that kind of stuff we want to make sure we take care of in step 5. Next example. Example 2. We have negative 3x squared minus 6x times, we have 2 parentheses next to each other, 12x cubed plus 11. Step 1, we're going to distribute each monomial. So we're going to take negative 3x squared, multiply by 12x cubed right here. Then we're going to take negative 3x squared and multiply by 11 right here, positive 11. Then we're going to take negative 6x, multiply by 12x cubed right here. Then we're going to take negative 6x, multiply by 11 right here. So once we do that, the next step is to multiply these together. So we're going to do negative 3x squared times 12x cubed, which gives you negative 36x to the fifth. Then we're going to take minus 3x squared times 11, which gives you minus 33x squared. Next, negative 6x to the first times 12x cubed gives you negative 72x to the fourth, right? Finally, negative 6x times 11. 11 times minus 6, minus 66, and the x carries over, so it's minus 66x. Then we're going to go ahead and put these in descending powers for step 3. So we have the x to the fifth term first, followed by the x to the fourth term, followed by the squared, and then x, which is a power of 1. For this particular example, we do not have any constant numbers. And then step 4, we can check off because none of these terms are alike. They all have different exponents. Even though the variables are the same, the exponents have to be the same to combine. And then step 5, it's already simplified, so this is going to be our final answer here. We have 2x minus 3 times 4x minus 7. Okay, so we're going to do the 2x times the 4x, which is right here, then the 2x times the minus 7, which is right here. Notice there's a plus here because the 2x is positive. If it was negative, it'd be minus 2x. Next, minus 3 times 4x right here, and then minus 3 times minus 7 right here. For this example, we're going to do everything on the same slide. So step 2, which is multiply. We have 2x times 4x, which is 8x squared. 2x times minus 7, minus 14x. Minus 3 times 4x, minus 12x. Negative times a negative is a positive 21. Final step for this example is to combine these two. Minus 14x minus 12x is minus 26x. So that would be our step 3 combining. And then once we do that, we want to, well, they were already in ascending powers, excuse me, they were already in descending powers, so we didn't have to do anything there. Then we combine them for step 4, and finally, that's it. It's simplified, right? 8x squared minus 26x plus 21. Does anybody know what a polynomial with 3 terms is called?
Binomial.
Trinomial. Yes, this is called a trinomial.